Hello everyone, my name is Meher Farouk and I'm from the department BS Biotechnology. Today, I will discussing you a topic which is gum rosin. Let's begin with an overview of the chemistry, manufacturing and the applications of gum rosin. So first, I'm going to tell you about gum rosin. So basically, gum rosin is a complex polysaccharide. And this polysaccharide is composed of multiple monosaccharide units, which is usually glucose, mannose, and galactose. It's just a little bit of overview. Next is history of the gum rosin. So, plant exudates is used for thousands of years, like in adhesives, cooking, and traditional medicines. The exact history of rosin gum is unclear, but its uses are comparable to other natural gums. Historically, natural gums were used for their soothing and thickening properties in traditional medicine. In traditional uses, like Americans used plant exudates like gum rosin in their daily life. These gum were used to thicken broth, sauces, and also play an important role in adhesives for woodworking, textiles, and pottery. The recognition of the gum rosin in science and industry as during the Industrial Revolution, the natural gums like gum rosin become valuable in food processing and like in pharmaceuticals. Advances in the extraction processes allow for higher purity and commercialization of these gum. Next, I'm going to tell you some of the current uses of these gum. So gum rosin is used in various industries due to its beneficial properties. It serves like as thickener and stabilizer, emulsifier, and in many applications. So the history ends here. Next, next I'm gonna tell you about the chemistry of gum rosin or chemical structure of the gum rosin. As I already tell you that the gum rosin is a complex polysaccharide which is composed of multiple monosaccharide units. So talking about the functional group, the gum rosin have several hydroxyl groups which contribute to its solubility and ability to form hydrogen bond, which give its thickening and stabilizing property. The molecular weight of the rosin gum can vary, but it typically high due to the long chain and branched structure of polysaccharide. As I tell you that these three monosaccharide are generally used in the formation of gum rosin, and these are hydroxyl group which result in the thickening and stability of the gum rosin. Next is the manufacturing. So in manufacturing, I mentioned two process. First is a natural extraction and second is the laboratory synthesis or synthetic productions. First, I'm going to tell you about the natural extraction. So, the natural extraction of the rosin gum involves specific plant to collect their exudate. First, we have to recognize that which plant produce rosin gums. This process includes making incisions into the bark, allowing the gum to ooze and harden. The hardened gum is then scraped off and purified through filtration and centrifugation. Filtration then removes the large debris, while centrifugation separates the finer impurities based on the density differences. The next most important step is environmental consideration because it's play a very crucial part to ensure the sustainability of the plant. Next is the tell you about the natural extraction. Next is the synthetic production. And the first process is polymerization process. The synthetic in synthetic production Saccharide like glucose, mannose, and galactose are polymerized through a controlled chemical reaction. This process is carefully managed to replicate the natural polysaccharide structure of our rosar gum, which we have to make. Here are a polysaccharide. I'm going to tell you about it. The structure that I provided represent a simplified description of polysaccharide chain, which illustrate the backbone structure of the gum. The This O represents the oxygen atom, which are the part of the monosaccharide union, forming the backbone of the polysaccharide chain. Okay, this part represent the glycosidic bond between the monosaccharide unit. It formed when a hydroxyl group of one monosaccharide molecules react with the hydroxyl group of other monosaccharide, resulting in the release of water molecule. This linkage connects the polysaccharide units and form a polysaccharide chain. This part represent the remaining hydroxyl and hydrogen group of the monosaccharide unit, which are important for the chemical properties of the polysaccharide, including solubility and the importance of the chemical properties of it. So, polysaccharide may be in the form of branched or it may remain linear. Here I mention an example of branching. It is same as described first. The change that occur is in this chain. This branching or this part indicates a branch point in polysaccharide chain. A branch occurs when a monosaccharide unit attaches to a hydroxyl group of another monosaccharide unit, forming a side chain. So, branching increases the complexity and diversity of the polysaccharide unit. So, our synthetic production ends here. I'll tell you about the natural production and the synthetic production. Next is the processing steps. As I already tell you about it, that the rosogum passed by the filtration and the centrifugation. The filtration remove the impurities and centrifugation separate the thing based on the density. It also passes through some tests like drum drying test, etc. And the end product or the gum is in the form of powder. Next is our goals of packaging. I mentioned four goals here. First is protection, preservation, convenience, and compliance. So, I'll tell you a detail about it. The packaging is a critical step because it has to protect the gum from contamination, moistures, light, and physical damage. It also ensures the quality and stability of the gum over its shelf life, providing convenience in the handling, storage, and transportation. Packaging must comply with regulatory requirements for like labeling and safety. Proper labeling and quality control throughout the packaging process maintain the integrity and the safety of the product to use. So, these things are under consideration when they do the packaging of the gum roser. So, next, the application of the gum roser. As I tell you, due to its various application, it is most common use. So I mentioned some of here like in food industry, thickener, pharmaceutical industry, cosmetic industry, and its industrial use. First, I'm going to tell you its use in food industries. So roser gum is widely used in food industry due to its solubility, viscosity, and stability. As a thickener, it is used in soap, sauces, graving, and dressing to enhance texture. First thing, I'm gonna tell you that the gum roser only enhance texture, but does it alter the flavor of these products, which are natural in it? Talking about the gum roser as a stabilizer, it is used in drink, yogurts, ice creams, and salad dressing to prevent the ingredient separation. It also acts as a texturizer and low-fat product and an emulsifier in margarine, spreads, candies to blend the oil and water, ensuring the product stability and uniformity. So this is the application of the gum roser in food industry. It uses thickener as a stabilizer, texturizer, emulsifier. Next is the use of the gum roser in pharmaceutical industries. So in the pharmaceutical industry, roser gum is used like in drug formulation. I mentioned as a mentioned here that it is used as drug formulations, such as controlled release of tablet, as it is written here, tablet with controlled release, suspension, emulsions. It binds the disintegrates tablet to control the release of the medications, stabilizes the suspension and emulsions of the consistent dosing, and it also acts as excipient. The gum roser also acts as an excipient as I mentioned here, agent of excipient. It improves the drug efficiency and stability. Additionally, it also serves as a giling agent like in lotion, ointments, and gels, which enhance the ease of the application and the adhesions to the skin. So, this is the role of the gum roser in pharmaceutical industry. Next is the use of the gum roser in cosmetic industry. In cosmetic industry, it also acts as a thickener. So roser gum is a valuable in the cosmetic industry as it is used as a thickener. It gives creams, lotions, gels, a viscous texture. It stabilizes the shampoo, conditioner, body washes, like to prevent the separation of the ingredients. In product like makeup, moisturizer, sunscreen, it stabilizes the emulsions because it has to ensure a consistent high quality result. So, the gum roser in the cosmetic industry stabilizes the makeup, sunscreen, etc. It also gives a velvety and thick texture to the gels, moisturizer, and also stabilizes the shampoos, brushes, and conditioner to prevent them from the component separation. So, I'll tell you about the three application. First is food industry thickener. Sorry, second. Second is cosmetic and pharmaceutical. And now I'm going to tell you about its industrial uses. So, beyond food and pharmaceutical, Rosergum also have several industrial applications. So, it is like using adhesives to enhance the bond strength and increase the viscosity and tackiness. Talking about the coating, like paints and varnishes, it improves the application and ensures a uniform finish. In paper and textile industry, as I mentioned here, paper and textile industry, it is used in sizzing and finishing the smooth surface and improve the printability, and durability. The next application of the gum roser is in the personal care and health product. Roser gum is also found in personal care and health products like first is dental care. In dental care products like toothpaste, mouthwashes, it thickens and stabilizes the formulation. As a dietary supplement, it acts as a natural thickening and stabilizing agent, maintaining the consistency and stability. Its natural and biodegradable properties make it suitable for sustainable and eco-friendly formulations. So, our applications end here. Next is the last topic is its summary. So, I'm gonna sum up the all the topics that are present today. In summary, the roser gum is a versatile ingredient with applications across various industries due to its thickening, stabilizing, texturing, and emulsifying properties. Its natural origin was biodegradability, make it an excellent choice for sustainable formulation. So, in the end, thank you so much for your attention, and I'm going to share one more thing. Here are the references for which I take the material. These sources include the study of the chemical composition and application of the gum rosers, as well as the industries which practices for extraction and processing. So, my topics end here. Hope you understand it. Thank you so much, and Allah Hafiz.